In this experiment, we tested if the initial temperature of water before boiling has an effect on the speed at which it boils. We decided on this project because of the myth that cold water boils faster. In order to get these results, we used 5 different temperatures and we tested them 3 different times. We used cold water, hot water, iced water, room temperature water, and water we heated up prior to the experiment. The independent variable is the amount and the temperature of water placed into the beaker, and the dependent variable is the time that it took for the water in the beaker to boil. Our hypothesis for this experiment was that the hotter water would boil faster because it has a higher starting temperature than the colder waters. The materials you will need are listed in this picture below. After getting your materials, put on your eye protective goggles. Remember, safety always comes first. Now, obtain 2 600 milliliter beakers. You'll only use 1 beaker per test. This is because once one of the beakers are used to boil, the other beaker will be helpful for the next test, so the first beaker can cool off. The next thing you will do is set up your Bunsen burner. Push the hose as far onto the gas as possible. Wiggle the hose slightly to make sure the connection is secure. Then, make sure the windows on the burner are closed before lighting. Then measure 200 milliliters of either of the 4 temperatures. If the temperature is ice water, make sure to put only 100 milliliters of water in the beaker so when the ice melts, the amount of water will be the same as the rest of the tests. Then grab your temperature probe and record the temperature of your water. Take the temperature probe out of the beaker and place the beaker onto the ring stand. Then check to make sure that the Bunsen burner is still in its right place. Turn the gas on by turning the nozzle horizontal to the hose. Then start the Bunsen burner. Open the windows after you've started the Bunsen burner. Then immediately start the timer. And put the temperature probe into the beaker. Now, wait until the temperature reads 100 degrees Celsius. When the temperature reads 100 degrees Celsius, stop the timer immediately and turn off the gas. Take the temperature probe out of the beaker and use the tongs to gently remove the beaker from the ring stand. Make sure you keep your face away from the steam while pouring the water down the drain. Now set the beaker into the sink because the beaker is still hot. Then repeat this procedure for each temperature 3 times. From the data we collected, the starting temperature that had the fastest rate of boiling was the room temperature. The second fastest was the heated temperature. Then the ice water came in third, while the cold water placed fourth. The hot water surprisingly did the worst out of the 5 temperatures. Using only the data we as a group collected, we still have yet to find out whether cold water boils faster than hot water. In order to manipulate the experiment so our question can be answered, we could set each trial at the exact same temperature to see which one boils fastest. We researched this topic online and found an article about it in the New York Times. This article states that although colder water gains heat more rapidly than hotter water, it does not necessarily mean that it will boil faster. According to the New York Times and the scientists they used, the statement, "cold water boils faster than hotter water," is false. However, the article also reports that the reverse phenomenon can occur. This meaning that hot water can freeze more quickly than cool water. This is because hot water loses mass from evaporation and less energy is required to freeze it.